So I was getting some emails from parents and some questions about textbooks and stuff, so we can answer that later also. But I do know that Apex is not great for covering all the basics, so we're going to do some stoichiometry today. And stoichiometry it's not easy. It's not terribly difficult, but it's fundamental for everything else that we're going to do. So we'll have little interactive component while we're doing things, maybe some note taking. But this is more like a traditional lecture than I normally like to do for us. But let me get this screen up here. So one of the things about AP chemistry is it does assume that you've already had a little bit more basic chemistry and the basic course structure. So I like to call this lecture, How Do We Do This Stuff? Because that's what stoichiometry feels like in the beginning. And this question is from the you do section of Apex that I did not assign because I wanted to use it for our examples, but you guys can go back and reference it too. So this is one of the word problems on Apex 1.2.7. So if you guys want, you can tab over and pull that up so you can see the whole thing. You also will probably want to snag your periodic table right now because that's going to come in handy. And the questions these are real, by the way. This is like for real how we use chemistry in real life. But NASA used canisters filled with lithium hydroxide to remove carbon dioxide inside the space shuttles. So lithium hydroxide is a powder, and they would fill some canisters with it, bring them up into the space shuttle, and then they're called air scrubbers. They'd take out the carbon dioxide. It would make water as a byproduct, which is pretty cool. And the first question is, determine the theoretical mass of lithium hydroxide required for each 5 grams of CO2 that is removed from the shuttle. How do we feel about that question, guys?
Not too confident.
Exactly like that.
Yeah, I'm working on my meme game for you. So don't worry. All stoichiometry problems have the same format. The first thing that you need to do is figure out the molar masses of the chemical species, that's our fancy word for the individual chemical types that you need to answer the problem. In this case, the problem said carbon dioxide and lithium hydroxide, so we need to get those. You can simplify it out. I wrote out the long form for the 2 things that I remember off the top of my head. But we've got carbon. Carbon's molar mass is a skosh over 12. Oxygen's is a little under 16. Then what's lithium's?
6.94.
6.94. And hydrogen?
About 1.
Yeah, 1. So what I want you guys to do, we're going to take a moment in the alone zone to do this, but I want you to work out one or both of the molar masses and type it into the chat, but don't hit enter yet. So it's CO2 or LiOH. And we'll come back in like 2 minutes and we'll hit enter and see if we got the same answers. when you've got one of them, you can give me like the yes or a thumbs up in the participants window.
Flip your thumb, Adrian.
That's funny. So it looks like it's most of us. So let's go ahead and type it into the chat and hit enter. All right. Looking good. I think we've all got the same ones. I'm just looking. So there is just a couple of us who are off and not by too much from each other. So when we're doing these guys, I did my math longhand for you. What you want for like carbon dioxide, you take 1 times the mole of carbon, and writing this out long form is really silly for something that you almost do on your fingers. And then 2 times the mole of oxygen. So sometimes we forget to double the oxygen and we just did 12 plus 16, and that's going to give us what, 28 instead of 44. So that's pretty different. For the lithium hydroxide, it's lithium plus oxygen plus hydrogen, and the exact number is 23.95. In the case of this problem, they're only giving you, what, 5 grams? So the significant figures are pretty relaxed on it. So we get this together. Hang on. There we are. And we have our either or poll because you guys got the math right. So we're going to just pick one. What do you guys think about pineapple on pizza? I think one of us can't get the vote thing going. It's all right. That was pretty quick and pretty decisive. And I don't know, guys, 77% no's? Where are my adventurous eaters at? Not even a discussion. I got more discussion for the Xbox versus PlayStation out of everyone.
You know, if you people were smarter, you'd know that the sweetness of the pineapple counteracts the saltiness of the pizza and therefore is a perfect combination.
And you won't taste anything because it cancels it out.
It's the texture that ruins it for me. It's, I'm sorry. I can't with like I can eat the pineapple itself. It's just I can't eat that on a pizza.
So you know why I stuck this into
Yeah,
chemistry class. There's something in pineapples that pre-digests the food for you. You guys remember that?
Is like the acids of the pineapple.
Not just acid, it's an old biology term.
Oh.
It's a chemical that does stuff for you, but we'll come back to that later. I'm just planting seeds for now. But yeah,
I like regular pineapple. Why would I put it on pizza?
I mean, because it tastes good.
Oh, I like apples, but why put them in a pie?
It's like putting like juice on your pizza. It's just no.
It's like dumping Oreo in like orange juice just to feel something.
What if you had pineapple juice and then you put it in a blender with pizza?
Okay. Well, why? But why?
I'm telling you guys, pineapple on pizza just tastes good. You're coming up with ridiculous things to compare it to.
I just like cheese
Some people
pizza.
just want to see the world burn, you know?
So I got the problem up on top, and we got the first part together. Now putting it all is kind of weird, and it takes some getting used to. So this didn't line up properly here. I had to make it a picture to line up on the bottom. But we're going to use the molar masses to convert grams to moles. In this case, it's the 5 grams of CO2 to moles. And when you start off, it's always going to be the number that you're given in the problem, and then multiplied by, we've set it up as a fraction, so that 1 mole is on top and the grams per mole is on bottom. Now, when we do the math on this, this is always the fun part with the annotate. When we go through, we get to, let's see, we'll just X it out. We have the gram CO2, and we get to X out the gram CO2 there, and our answer is just going to be in moles of carbon dioxide. Now, really, as you go through these problems, if you do the math at each single step, you will get the right answer, but it will take a lot longer, and it may be problematic. There's more chances for mistakes. So what I do, and this is most of the work that we do in stoichiometry, is just continuing to set up the problem. So it's just setting up. We're not hitting equals. We're not doing any math. And I promise this seems weird at first, but you guys are gonna really enjoy doing the setup, and it's just putting together a bunch of fractions. So we have that 5 grams to moles business. Oop, let me go back. And then we've got our carbon dioxide moles to lithium hydroxide moles, and then moles of lithium hydroxide to grams of lithium hydroxide. So all the things we need are where we start and where we want to end up, our balanced chemical equation, and of course, the stuff we pulled from the periodic table. So I want you guys to use the annotate feature. It might be easiest to put the numbers in as a text thing and just kind of like float a number like in front of the moles. So we have that, how many grams and how many moles of lithium hydroxide. We should be able to pull up a number at the end. So I saw Ali getting on that. Oh, there we are. So where does that 2 come from? Kind of make your thinking visible for us. Yes, the 2 from that balanced chemical equation is getting dropped down there. We can even kind of do this and make an arrow to it. There. So what number is going underneath here? So a couple of us put a 1. Now I don't, yeah, you had to write the 1 there. I was gonna say, I don't see a 1. So if there's no 1, we assume that there is a 1 in front of that particular, again, the fancy term is chemical species. Good. And there's a lot of 1s as placeholders. All right, where'd 1 gram come from, Diego?
Sorry, I was trying to put 1 for the mole.
Okay. Yeah, so how many grams per mole of lithium hydroxide? Where did we have that? Well, I mean, 21 is close. I'm looking in the chat window for all of our work on it. Yeah. Now, before we get to the whole answer, whose head is currently hurting? See you raise your hand, Gavin. What can I help you with on this?
I'm just not following the process.
All right. So we're given the 5 grams of CO2 in the problem. Good so far? Excellent. So we have to compare, I mean, this is like comparing apples to oranges. So we have grams of carbon dioxide that go into this chemical reaction. And we want to know how many grams of lithium it's going to use. So that's our lithium and our CO2 coming together. To compare them, we do need to first change from grams to moles, because just 1 unit of CO2 turns out to weigh a lot more. Then we have this funky mole conversion step, this ratio, which is about the numbers that are in front of each of the chemicals right there. That is the one that's the easiest to skip in all of this. Then what we'll really have in this is we'll have first an answer in moles of carbon dioxide. Then, hang on, let me get this stamp here. So when I cut out the grams, it's going to be moles. At the next step, the moles on the bottom of the fraction cancel out the moles on the top of the fraction. So what I have is moles of lithium hydroxide. So this is kind of my conversion idea here, where we're going from grams to moles to the other kind of moles, and then we want to come out grams at the end. So this is all about setting up a long multiplication of fractions so that we can keep canceling units. And in the end, all that's left is grams of lithium hydroxide. And I know it's weird. I don't expect everybody to get it solid yet. And then the rest is what we affectionately call plug and chug, where you just plug all of the numbers into your calculator and you go. How many of you that have been working have an answer? What do you got, Zachary?
I got 1 point.
You got
grams.
1 gram?
Yeah.
All right. Now I'm going to type this out in a straight line for what I plug into the calculator. But you'll take the numbers on top, and I'm leaving in all the ones, and plug it in like that. Can you guys see those numbers now? Looking in the chat. Ah, Ariella got something radically different than 1. Somebody asked me where the 24 came from. That is what we did previously. It was really 23.95, I think, grams per mole of lithium hydroxide. So now we're getting a few more 5 and change. And here's where it gets tricky. When I'm typing these in to a calculator, once I've done the top, I've got to just divide by everything on the bottom. And hitting the divide button in between everything feels really, really strange. So here's the equation as I would punch it in, just straight out. And I multiply everything on top and then hit divide for everything on bottom, even though it's a bunch of 1s here. And you could really cancel out all the ones. Now the long sprawling version that I made look pretty for you guys to see, hang on, go away, is here. So this is me setting it up in Microsoft Word and using the equation editor to make it nice. So these guys are molar masses. This is given in the problem. That's what we're asked for at the end. And finally, that thing in the middle is that mole conversion step. Yeah. And it's just 5 times 2 times 23.95 divided by 44.01 in the end. All the ones cancel out. And that is every single stoichiometry problem will follow the same idea. You'll be given one thing, asked for another. We're going to have to make sure that we have a balanced chemical equation to do mole conversions, and we're going to have to look on the periodic table. Do you have questions about that one? Good so far? Then we're going to move on to the question B. And I want you guys to tackle just the setup for question B. I was going to drop you into some breakout groups. While you are there, can I have you guys hit record for me so that we can see about getting a recording of every breakout group? I'm going to try this system, make sure it works. Was that a yes? Yeah, so we're going to give it a shot. Awesome. Do you need to screenshot this, or do you have the assignment up already in another tab? Well, I can also push this to you all. That is another option. But see if you've got the other tab open already. That'll probably be easier because it has all the other equations on it. And we're going to give this a shot, sending you all into breakout rooms. And I will pop in to see how everything is going in there. Ready for it? Any questions before you go? All right, have fun, kids.